Hello everybody and welcome back. In this episode I'm going to show you how we can do a simple bouncing balls example. In this example, the main thing to get out of that episode is we're going to add a gravity force, we're going to add a velocity damping to our rigid bodies, and we're going to do a very simple collision resolving step in our simulation. Yeah, then let's jump into the code to the rigid body class. Here you can see our last code in the last episode. We did the integration things. For this episode, I'm gonna use the Semi-Implicit-Euler all the time. I could use this one too, but yeah, I'm gonna just use the semi-implicit. I used it basically anytime, everywhere in my code. All right. In the integration part, I want to scale the velocity by 0.99. And if we go back to the browser now, refresh, and if I press the arrow key now, or the D thing, the D button on my keyboard, you can see the velocity is decreasing. If I press it a little bit stronger, then you can see the circle will slow down. And this is simulating, well, air resistance. Okay. Then jump back to the code again. And now I'm gonna, well, I think actually I'm gonna do that in the integration part. So I'm gonna copy this scale here and set it right above the force accumulation. You can also set this below it, it doesn't matter. Okay, and that's it for the rigid body class. Now I'm gonna jump to the simulation class. And here, I'm gonna change the circles. I think the first one is fine. I'm gonna set the mass to 50. The radius to 50. Then the other one, I'm gonna change the position here to 300, 100. This is the radius to 100, the mass to 10, that's right. And then I'm gonna add another circle. And this will be 1000. Also 100, a radius of 75, and a mass of 10. Okay. Also what I'm gonna add is a gravity. So I'm gonna say this dot gravity is a new vector with a 0 and 5000. It's just a force, any force you like. Then in the update method, between this loop and the update, I'm gonna add this force to any rigid body. Sorry, I need to say rigid bodies. Come on, this dot rigid bodies. Add force, and this will be this dot gravity. This dot gravity. Okay, and then if we go back to the browser, we should see an acceleration to the bottom. And there we go, there's our acceleration. Awesome. But as you can see, it will move out of our canvas. So I'm gonna constrain this one. And I'm gonna say that the rigid bodies, the center of the rigid bodies, I'm not quite sure if I have this get center method already in the rigid body class. No, I don't think so. Okay, then I'm gonna say here above it, the center is this dot rigid bodies get shape dot centroid. This should work. Just gonna check it again. Shape. This dot position. Does it have a centroid? It must. Yes. Okay, yeah, that should work. Then I'm gonna say if this dot center, if the center plus the radius of the rigid body. So I'm gonna say here also that radius is this dot get shape. I'm just gonna copy this one. And here I'm gonna say radius. Of course, you only can do that to circles. If you have a rectangle in here, then it's not gonna work. Plus the radius is greater than, let's say, 710. Then I'm gonna say console.log invert velocity. Okay. And I forgot to change the screen again. What I did, damn it, was to get the center with this dot rigid bodies, get shape centroid, then get the radius with this dot rigid bodies, get shape dot radius, and then if the center y plus the radius of the shape is greater than 710, we're gonna invert the velocity. Okay. Yeah, sorry for this. And now we should see in the console that we have to invert the velocity. Of course, I did an error there. Yeah. I need to move this one in here. Save it again. Go to browser and let's see. There we go. And we need to invert the velocity of three objects, and that's right. Okay, cool. Now we can, well, we're gonna invert the velocity, and this is really, really easy. We're gonna say this dot rigid bodies at this index, at the current index. We're gonna say set velocity. Also get the current velocity before, so let velocity is also this dot rigid bodies, the current index dot get velocity. And here I'm gonna say scale the current velocity with -1. And now we inverted the velocity. Now we can go back to the browser, refresh, and now we should see that the velocity is inverted. And it will hopefully bounce, but it's not gonna bounce. And why? Get velocity is not a function, so probably I forgot to add a get velocity function in here. Yeah, there's only a set velocity. I'm just fastly gonna fast add the velocity here. So get velocity, return this dot velocity. Okay, now it should work. Go back to the browser, refresh, And there we go. Our balls are bouncing. And now you can see a short thing we need to tackle later. And this is the, yeah, they vanish anyways. This phenomenon we're gonna tackle in the collision detection, or in the collision manifold step. You go back to the code and you go to the collision manifold, you will have a resolved collision. This will be the things we did in this example with the bouncing balls example. And then we have a positional correction. And the positional correction method will handle this disappearing we see in our browser. But yeah, this will be something for, I think in the next 4 episodes we're gonna handle impulses, and then you can see what we're gonna do there. Okay, that's for this episode. See you in the next one. Bye bye. Yeah, and sorry for my little mistake with the screens.